So today we're going to look at our exponent rules. The first one is the product rule, which says if we are multiplying two things with the same base, we will add the exponents. For example, 2 to the second times 2 to the third, we would add the exponents and get 2 to the fifth. The power rule is when you're multiplying the exponents together, and that's when you have a power raised to another power. Power to a power, we multiply. So for example, 2 to the third to the second, we would multiply those to get 2 to the sixth. The quotient rule is when we're dividing, and again have to have the same base, we will subtract the exponents. So for example, 2 to the 10th divided by 2 to the 4th, we'll subtract those and get 2 to the 6th. And the last one is our negative exponent rule, which says if we have anything raised to a negative exponent, it will move spots down to the denominator and become positive. I'll do 2 examples for this one. We could have 2 to the negative 2 power, which would become 1 over 2 to the positive 2 power. Another example would be if we had 1 over x to the negative 3 power. If the exponent with the negative is in the denominator, it'll actually come to the numerator and become a positive. So technically x cubed over 1. Okay, so we have some examples with numbers and with variables. What power will we use first here? What property? Good. We'll use the product rule. We're going to add those. We'll get 3 to the 11th. So that's exponential form, and then we also want to evaluate, so we'll type that in our calculator and get 177,147. Next one, what rule are we using? A power rule. We're going to multiply those to get 2 to the 18. And evaluate that in your calculator. I'm not doing that by hand. And what property are we using on the last one? Good, the quotient property. We'll subtract those. Get 5 to the first, which is 5. Try the next few on your own, and we'll go over those in just a minute. Remember that anything to the 0 power is always 1. And if you're not sure, you can test that in the calculator. And for example E here, you might want to put a little 1 exponent if there isn't an exponent. Remember, we will subtract. So 2 minus 1 will get me x to the first. 1 minus 5 will get me y to the negative 4th. Remember, we can't leave a negative exponent in our problem. So what we're going to do then is we're going to take this and move it to the denominator. So this will become x over 1. If you want, you can leave a little 1 there. Okay, now for scientific notation, multiplying in scientific notation. All you're going to do is actually multiply the decimals. You'll use the product property, which tells us to add the exponents, and then we will rewrite in proper form if necessary, because the number that comes before our times 10 to the, say, third, this number has to be between 1 and 10. Okay, so sometimes we'll have to rearrange it. So all we're going to do is we're going to multiply 2.1 times 3.2, and we will get 6.72. Then we're going to take and add the exponents, so we'll have 6.72 times 10 to the 7th. Next one, again, we're going to multiply our numbers together, and you can just do that on your calculator if you'd like. We'll get 17.86 times 10. Again, add our exponents. We'll get to the 14th power. Now the problem with this one is that this is not in standard form. It's greater than 10. So what we're going to do is we're going to make it smaller, moving the decimal 1 place to the left. When you make this number smaller, you have to make the exponent bigger. So we're going to add 1 to the exponent. So that gives me 1.786 times 10 to the 15th. This is standard proper form. See if you can try example 3, A and B on your own, and then we'll go over those. So we're going to take a look at our answers here. We do have this one not in proper form, so we have to make this smaller, which means we have to make that bigger. So we should have 1.428 times 10 to the negative first. And our last set is on dividing. Similarly, we're going to divide our decimals just like we would. This time we'll use the quotient property, which says to subtract our exponents, and then we'll rewrite in standard form if necessary. So we're going to divide 8.4 divided by 4. So 4 goes into 8 2 times, 4 goes into 4 1 time. And we have to subtract the exponents. So it's negative 7 minus a negative 4. So that's really negative 7 plus 4, which will get me a negative 3. So this will be times 10 to the negative third. Next one, same thing, divide our numbers. 3 goes into 6 2 times. 3 goes into 9 3 times. And what will I get when I subtract my exponents? That's right, negative 6. Okay, now for the last one, we have to divide our numbers. So that's going to get me 0.75. Subtract our exponents, that'll be times 10 to the fourth. Now again, this is not in proper form because this has to be greater than 1. So we're actually going to move the decimal to the right 1 time, making this number bigger. When you do that, you have to make the exponents smaller. So it's always an inverse relationship. When one gets bigger, the other gets smaller. So 7.5 times 10 to the third. And then go ahead and complete the closures. I'll get a few of you up to the board to show your work. Okay, and then you can see our assignment is here for you to complete.